And welcome everyone to Red Planet Live. I am your host, Ashton Zeth. I am elated to be hosting the Mars Society's podcast and leading the conversation about human exploration of the universe and the future settlement of Mars. As a longtime space enthusiast, I am passionate about STEM education and making humanity an interplanetary species. Thank you so much for joining today and supporting Red Planet Live. It's going to be a great episode, so thank you for being here. Want to start off today's episode. Just a reminder, we have some exciting Mars Society news. The first is that Crew 16 has arrived on Devon Island. So Crew 16, known as the Arctic Wolves, has safely landed on Devon Island in northern Canada to commence an extended analog mission at the Mars Society's flashline, Mars Arctic Research Station. So this is an international crew of 7 members who arrived late this afternoon from Resolute Bay and have started setting up their equipment and supplies inside the 2-story habitat. We have confirmed Starlink communications are fully operational, and we're going to have more updates and photos expected either today or tomorrow. And this mission does mark the second mission to Flashline in 13 months to visit the facility, where the crews will conduct research and field studies in one of the most Mars-like environments on Earth. So to follow along with the crew's mission, please visit fmars.marsociety.org. All right, that's exciting. Second announcement. You've heard me say this, but it's coming up and we're excited. The 27th Annual International Mars Society Convention is scheduled for August 8th to 11th at the University of Washington in Seattle. This 4-day event will bring together leading scientists, policymakers, commercial space executives, government officials, media, space enthusiasts, everybody to discuss the pressing topics related to space exploration, technology advances, and the planning for human exploration and settlement of Mars. Now, again, like we have in the past, the Mars Society will again offer both in-person and virtual attendance. Attendees from around the world can join the conference, pose questions, and interact with each other. Remember, students are free, so if you're a student or you'll be at University of Washington, registration is free for you. More details can be found at www.marssociety.org. Okay. Fun stuff. I'm going to introduce today's guest. I'm very excited to be speaking with these 2 representatives from NASA, including Lindsay Hayes and Jude Moranci. Thank you so much for being here today.
Glad to be here.
Thanks so much. We're happy to be here.
Excited to be chatting with you. Okay, so first things first, quick introductions. So we have Jude Moranci, who is the Deputy Associate Administrator for the Strategy and Architecture Office in the Exploration Systems Development Mission Directorate. I can't even read. For the NASA headquarters, based at NASA's Johnson Space Center in Houston, Jude guides the technical aspects of exploration architectures, overseeing the annual architecture concept review cycle to refine NASA's efforts in returning astronauts to the moon, establishing a lunar presence, and landing humans on Mars. Jude, thank you so much for being here today.
Glad to be here. And sorry, my title has way too many words in it. So.
I'm like, I could read that 5 times fast, and I still think I would stutter on that somewhere. So thanks for bearing with me on that one. And next up, we have Dr. Lindsay Hayes, who is the Mars Samples Return Campaign lead scientist and the program scientist for the astrobiology program in the Planetary Science Division at NASA headquarters. Her research background is in mass extinction events. And since coming to NASA, Lindsay has worked on missions to Mars, Venus, the search for life, and future human exploration. Thank you so much, Lindsay, for being here.
I'm really excited to talk with you guys today.
Very exciting. And we were supposed to have a third guest today, but unfortunately, Eric Ianson was called away for an urgent family matter, so will not be joining us today, but we're keeping it the girls' club, and I'm excited to talk with you. Okay. Now, on Red Planet Live, we have a segment that we call the question of the day. It's just an icebreaker. I promise there's no right or wrong answers. It's just to kind of dip our toes into the conversation for today. So this one is going to be related to both of you. You work for NASA, you're scientists. I'm very curious to hear what answer you come up with. So today's question is, if you had the opportunity to name a newly discovered planet, what would you name it and why?
So I grew up watching Star Trek, and Geordi LaForge was my favorite character. So we're going to go with Planet LaForge.
I love it. That's a good one. I was watching, no joke, I was watching Star Trek Next Generation today. it's like a hype up inspiration sometimes. I just want to get in the right headspace. So I love your answer.
You got to have the engineer from Star Trek.
And Lindsay, what about you? What would you name your planet?
That's a great answer. I will say, you know, within astrobiology, we think a lot about exoplanets and what other planets around other stars might be like. But I feel like I can't give it just a name. I feel like I'd have to know a little bit more about the planet. Is it hot? Is it, you know, a hot Jupiter? Is it somewhere further out there? You know, I think I'd want to name it thinking of sort of the way we've explored as humans in the past. I think I'd want to take some characteristics of the planet, right? If it's something really cold, name it, you know, New Antarctica or something like that. If it's something really warm, name it, you know, something like that. I think you need to know a little bit more about something before you can give it a name.
That's fair. That is a very scientific answer, and I appreciate that very much. Well, I am not a scientist, so I would say if I were to name my planet, I'd probably call it like Jack's 56 or something. Jack is the name of my husband. I think he'd like the shout out if I could name a planet after him. So that's probably
there's a long history of naming things after people we care about too. So I think that's a great answer.
Just following with tradition. All right. Well, we are at the point in today's conversation. I'm sure you guys know we have a lot of attendees that are listening, that are tuning in today, and they've already submitted some questions. So we're going to jump right into the conversation. I want to dive into the deep end, and we're going to start with our favorite topic, which is Mars. This is the Mars Society. So Mars seems like a good place to start. So the first question I have, this can be for both of you. Mars has captured the imagination of scientists, explorers, public alike, myself included. I'm wondering, can you share your thoughts on why sending humans to Mars is a pivotal step in the exploration of the universe? And what do you think that represents for space exploration as a whole?
I'm gonna let you take this one first.
Okay. So I think there's many aspects to this. Like, first, in general, why do we even explore, right? It goes back to because it's hard, right? Mm-hmm. We learn how to do hard things. We solve hard problems. We capture the imagination and the inspiration of doing so, all those things. And then especially for human exploration, we're using Mars as that long-term anchor goal, because if we're looking to develop the technologies and systems to get to Mars, we need to test those on the moon. It is that so far away that we have to do really hard things to achieve it, but not so far that you just throw up your hands and say it can't be done. So it really is a driving goal. And if we can achieve Mars, then we're achieving solar system exploration.
Absolutely.
You know, and I'd also say that out of all of the surfaces, right, we have to send people to surfaces somewhere else, right? Of all of the surfaces we could explore in our solar system, the surface of Mars is quite similar in a lot of ways to the surface of our planet, right? Although overall it's colder on Mars. There are days when places on Mars are warmer than places on our planet. You know, the environment has a lot of similarities. And I think that Mars, I love the way you said this, it's Mars is the stepping stone, right? Mars is the way we start moving out and beyond, you know, the Earth-Moon system and further away. And we have this fantastic history of robotic exploration of Mars as well. We've collected a lot of data, more than 50 years on the surface of Mars, not continuously yet, but we're working there, and I think we'll achieve it in not too long. But you know, we know a lot about another planet in our solar system, and that's a great place to think about you know, our next step of exploration.
Absolutely. And can you speak to just at least at a high level, you know, Mars is where we're trying to get. We've obviously got the rovers like Perseverance and Curiosity that are on the surface now. We're talking about humans to the moon. We're talking about humans to Mars. What could potentially be after that? Like long-term goal, we get to Mars. What's next after that?
I mean, we're trying to set up a process to make sure that once we achieve something, we keep setting our sights further. So that's really part of the goal, is how do we make sure we're constantly exploring and not stopping and going back like after Apollo, for example.
Sure.
But I think when you look beyond, like, that's where we start looking at some of the current robotic missions. Is it the moons of Jupiter and Saturn and all of those where there might be water on, you know, Titan and things. So I think that's where you look next, because you look to go where there might be a resource or a reason for going. And so I think that when we really think big becomes that next step of what might be.
Yeah. Agreed. We've had an opportunity to speak with others on the podcast, including Dr. Graham Lau from astrobiology with NASA. And, he was mentioning the same thing that with like Titan and Enceladus, like there's reasons to potentially go to those. So it's exciting to see that, hey, we're not just thinking about the moon. We're not just thinking about Mars. We're thinking about what's, the next few steps after that. But specifically with Mars, we know that recently there were some changes to the Mars sample return. I was wondering if you could give us a status update. Is there an ETA for Mars sample return? Is there new options for potentially returning the regolith samples that have been captured?
Sure. So Mars sample return, we recently underwent this process. It was the Mars Sample Return Independent Review Board, MSR-IRB2. And then we had it sort of investigated the whole program and tried to understand really, sort of where it was and everything. And in response to the findings from the MSR-IRB2, we had the MSR-IRB response team at NASA headquarters, because we love our nested acronyms at NASA. So the MERT findings essentially said that, where we're going to be going next with MSR is we're going to be undergoing a process where we really try and get some new different ideas. We recently had an open solicitation to folks within industry, within US industry, and said, what are some ideas you have either for the whole campaign, ways that you can do it for, less annual cost, less total cost, less complexity overall, bring back the samples at an earlier timeline, bring back more samples, or more than sort of a baseline number of samples. How could industry help us and partner with us as a way to do this in a better or improved kind of way? We had a fantastic response to that call. We got a whole bunch of great great responses from a number of different industry teams. Recently, we announced that we selected 7 of those. And so in addition to additional studies, one being performed by different NASA centers, one being performed by JPL, and one being performed at APL, towards the end of this year, we're expecting sort of 10 different studies looking at some different architectures, either the whole campaign or independent elements. And we're really hoping that can help us think about ways that we can sort of improve. I mean, certainly the goal, the interest is all there. We're just trying to make sure that we're, sort of good stewards of the government, taxpayer money and such. And we're doing this in a way that returns the samples and focuses on doing all of this in the most efficient way possible. And so that there certainly will be some changes that we expect, that we hope that we can find sort of ways that'll be improve on one or more of those elements. And, hopefully in the next year or so, we'll be able to come at this with a slightly adjusted plan. Although at this point, we don't know exactly what that is yet, or we don't have the details on that yet.
Mm-hmm. Stay tuned. I have to ask, do you go through a specific training for all those acronyms? I can't say the word. I don't know how you guys remember all of those. Just in the title alone, there must be some special training for this.
It's like learning a language. Like you start working, and then it's like you pick up the language of where you're working. So it's probably easier than learning, Spanish, but.
Comes with the other thing I was going to say is even within NASA, different groups have different acronyms or different meanings for the same acronyms. And so sometimes, even Najud and I work on similar kinds of things, both interested in Mars and things like that. And yet there'd be different acronyms between us. And sometimes that causes a little bit of communication when you think you're saying the same thing, but you're not.
I hope there's a directory somewhere, a key that has like every acronym you may need. There's a process for that somewhere internally. Well, speaking of the Mars sample return, one of the questions that we got ahead of time was about the criteria that NASA uses to determine the type of samples that may be collected. We're curious, how do you decide where those are collected from? Of all the samples that are collected, are all of those potentially getting sent back to Earth? What does that selection process look like?
Yeah. So we are extremely lucky that the rover that we have that's on the surface of Mars right now, the Mars 2020 Perseverance rover, is an extremely well-equipped, well-instrumented rover. And so as it's exploring the surface, as it's wandering, through Jezero Crater and the surrounding environments, it's not only, it has multiple jobs. Its job is not only to collect samples, but its job is also to make a whole bunch of measurements about, the rocks and the composition and a whole bunch of other things as it explores. And so all of that data goes to the science team for the Perseverance rover, who then say, okay, this is what we're understanding about this area. Because of what we're learning about this area, we think that this particular rock would be a really important rock to help us understand more about this area, to help sort of complement the data we've collected here in situ. Ultimately, when we bring these samples back and we have these samples in the lab, this particular rock can help us understand a number of different pieces. And so this great team of people, of scientists, who are looking at all of that data as it comes down from all of the different instruments, and helping to say, okay, this rock or that rock are the ones we should collect. And these two rocks together can really tell us more about this area than just one, than either of them could individually. Yeah. And then ultimately, we have 43 sample tubes were loaded onto Perseverance when it was launched. Currently, the architecture says that we could return 30 of those. That again, there's as we said, there's some changes. We're considering different options and such at this point, or we're looking for some new options as we have all these studies coming in. But currently, the architecture says 30 samples would come back, and there will certainly be, we've sort of envisioned the idea that, much like for a landing site selection process where, different individuals say, well, this is a really great place that we should go, we could have a similar kind of process amongst the science community, where they say, these 4 samples together could really tell us a lot about this particular science objective that we want to answer. So we should think about that and sort of have an opportunity for the science community and all of those, all kinds of different stakeholders to weigh in on that, and then ultimately decide which samples we would bring back. So there's a number of different opportunities for folks to, understand the data as it's being collected and as it's being brought back, and then ultimately, when we make that decision about which samples to bring back, hopefully that will be a lot of different inputs we can bring to that.
Okay, so we've touched on kind of the criteria for how we're selecting which samples come back. Once those samples do return to Earth, what specific information is NASA hoping to collect from those? Can you kind of allude to maybe some of the testing that may be done on those samples?
Yeah, I mean, honestly, I think we're hoping to collect as much data as possible about these samples. They will be absolutely precious samples, precious material. There have been a number of Mars sample return has been a thing that the science community, the Mars science community, and the sample science community have been thinking about and working on and conceptualizing for decades at this point. And so there's a pretty good set of things that folks have identified, different objectives that people have identified as the kinds of things we would want to measure. So things about the geological environment local to where the samples were collected. Are there sedimentary rocks? Are there igneous rocks? What do those histories look like? Was there groundwater moving through other hydrothermal things? Certainly life, the search for past biosignatures, past evidence of life or past evidence of habitability are things we're certainly very interested in. Things like geochronology. How old are the samples? What individual samples were deposited at different times? That can be really important for our understanding of sort of global geochronology, the whole timeline of the geology of the surface of Mars. And then, things for potential future human exploration, different compositional measurements and such that can really be done with return samples and tell us so much about what potential environmental hazards or resources may be, either at that site or part of this sort of globally distributed dust. And so there's a whole bunch of different investigations. I think, there's somebody who is interested in every single atom that we will bring back from Mars, and understanding what it'll be able to tell us about the surface environment.
I love it. Okay, so there's a lot. So you're saying it's simple. We're going to bring back and
basically everything.
It's going to get touched by a lot of different teams. There's a lot of scientists within NASA, different departments that all may be relying on the data that comes back from those samples.
And to be clear, not just scientists at NASA, but scientists, in the global science community. We're really thinking of these samples as for the global science community. These aren't just samples for NASA scientists or US scientists to be interested in. MSR, Mars Sample Return, is a NASA ESA partnership. And so at the very basic level, these samples are for more than just, US interests. They're globally interesting.
Mm-hmm. I'm curious, and maybe Najud, you could share some of this as well about some of the technology that's going into the Mars Sample Return and how that may impact potentially other missions perhaps humans to the moon as well. But I'm wondering, can you share some of the insights into the potential like technological advancements or innovations that are crucial to the Mars sample return, and how could those influence future space explorations, beyond Mars?
Yeah, I think there's a lot going into it. And since we don't know the final architecture, I can't speak to specific technologies. But I think, one of the things that's happening right now are people from my team that, when we talk about human missions, we always talk about returning them. Mm-hmm. So we are very familiar with studying the round trip mission to Mars and the implications that have. And that's less familiar to, say, the science community, which has mostly been doing one-way trips. So we've been loaning people to the science team, in this case for MSR, to study some of those aspects, look at different technologies. And I think a lot of what we're going to learn, right, essentially it all boils to all data is good data. Mm-hmm. So anything we collect will validate models that will eventually help later things. It will validate the science data. It'll validate our understanding of the soil, so we know that we're designing the right spacesuit. So any return data is always good because there's so much analysis and engineering going on that whatever that final form of the Mars sample return mission takes, it is data, and data that feeds the ecosystem of the entire NASA engineering and science community. So it's not just the scientists that looking for that data, the engineers are as well, because it just adds to our collective knowledge, which makes us better for everything.
Pivotal to everybody. Let's see. One of the questions that we've received already, and I've heard from other, Mars Society members, is about the moon and Mars. So if the goal is sending human explorers to Mars, isn't returning to the moon first likely to delay a potential mission to the red planet?
So to be quite honest, we've spent 50 years in low Earth orbit, and I think folks have not sort of internalized how hard going to the moon really was when Apollo did it. It's orders of magnitude harder than Leo, and going to Mars is orders of magnitude harder than the moon. So you can consider it a delay, but I consider it fundamental to learning how to operate off-world again and operate the technologies and learn how to do the operations we're going to need for the extended Mars mission. So to me, going to the moon is an enabling feature that we need to get to Mars. It is a huge leap. If we said, 2 orders of magnitude, so you're talking massive difference between Leo experience and Mars. So to me, and, all of the systems we have to develop for humans, we have to demonstrate those in a relatively near field environment, be able to do extended orbital missions followed by partial gravity. We haven't put people in microgravity and then in partial gravity in the last 50 years, and only 12 people total experience. So our health and medical team has a massive amount of knowledge that we need to gain to enable Mars. So it's to me fundamental to getting to Mars is also doing these things at the moon.
I love the way you phrase that too. It's almost like they made it look so easy and so cool that like people are just like, oh, why haven't we been back? Why the delay?
And Apollo is one of the rare things that the closer you study it, the more amazing it gets. It is just phenomenal what they accomplished. They truly made it look so easy that everyone's like, well, just do that. But
just do it again.
It was really that hard. And I can't explain that to anyone that, Apollo made it look easy in retrospect, but it absolutely was not.
Yeah, still an incredible feat, and one of the most pivotal things that we've done so far in human history.
Absolutely.
We focused on Mars, and we've kind of shifted into the moon. So I want to continue on that line of thought. So there are other major NASA initiatives. Clearly, it's been a long day that we haven't focused on yet. And one of those is specifically the Artemis missions. So can you share some of the latest details on Artemis and getting humans to the moon, including the first woman and the first person of color?
Yeah, so a year and a half ago now, 2 years, we had our first Artemis 1 mission. It was the uncrewed mission for SLS Orion and the ground systems. And we're building on that success. Obviously, we do a flight test, so we learn things. So one of the key things that we are incorporating into the vehicle design was Orion's heat shield. So they are going through in detail to make sure we understand the phenomena that occurred and that we're ready for the Artemis 2 mission. So I'm incredibly excited about the crew that's been selected for that flight. It's a different mission, right? And that's how versatile the SLS and Orion systems are, is every mission is sort of a different mission. You can do many things with the same vehicle. And that's intentional because you have to be able to plan for aborts and alternate missions and things like that when we do crewed missions. So Artemis 2 is starting assembly. And in fact, the core stage is going to roll out of the factory in Michoud, Louisiana, in 2 weeks. And then make its trip to Florida to start integration there. So the hardware is being built. And I think the last time I heard, we have hardware literally being built all the way out through the Artemis 6 mission already. So when we talk about how much is going on, there are literally things going on worldwide. So very excited about that. We're seeing the human landing system test flights happen, and our second provider is on. So we're starting to get lots of test data. So it's incredibly exciting for where the Artemis is at right now.
Very exciting. I'm excited to watch as those missions continue. I'm excited to see humans back to the moon. Maybe you could highlight, Najoud, maybe you can highlight the Artemis mission, some of those challenges. And Lindsay, maybe if you could highlight some of the challenges for the Mars sample return. We've talked about, hey, we're doing this incredible testing, this research, we're preparing for these missions. But what are some of the challenges that we're facing right now within these two missions, within NASA? What are some of the challenges?
So I'll start on that one. So, I mean, I'll say one of the challenges, like I said, going to the moon is hard. It is incredibly hard, and it is orchestrating all of the systems that are needed: the rocket, the spacecraft, the lander, the suits, having rovers to do things on the surface to get the science and make sure it's properly contained all the way from the moon back. It is, truly the biggest systems engineering problem you can work on. As a systems engineer, I get very excited by that. But that is the big challenge, is the complexity of what you have to do. And I think that's what you see in the Mars sample return too. You have multiple steps and multiple pieces that have to come together. And that's the challenge in these highly complex missions we're putting on.
Yeah, that was going to be my answer for Mars sample return is just the complexity. I mean, NASA doesn't do things because they are easy, right? NASA really challenges itself and as an agency and the US, the US partnerships that we have as well, to do things that are hard, to do things that are different, to do things that are difficult and complex. And that's really, that's the hardest thing about both of the things that, that we're working on, is that, none of this is easy. And a lot of this is, how to do things that have never been done before. Even going back to the moon, to your point, Najoud, it's an entirely different thing. We have more information, but, it's been enough time that we're doing new things. When we're thinking about bringing samples back from Mars, we've never brought samples back from another planet before. We've never had a round trip mission to another planet. We've never launched off of another planet before, either robotic or human, right? So all of these things are new and different and require people to think in ways and answer questions and approach challenges that are new and different. And that's exciting, and that's what makes it hard.
Sounds like there's some challenges that you've identified. We're working to develop a solution to those challenges, but there's many unknown as well. And new challenges will come up as we're going through this process. Well, I see we have a lot of audience questions so far. So I want to make sure that I give some time to them as well, and not be selfish and ask my own questions. But I see we have a question from Charles. It says, beyond the rocks, is the Martian atmosphere captured in the samples? That's a good one.
So there is one tube that had just atmosphere in it. It was one where we were trying to capture a rock sample. It was a little bit softer than we expected it to, and so we actually wound up not collecting the rock sample that we intended to. But when we sealed it, and now we have a sample of just atmosphere. In each of the rocks, in each of the tubes that we have filled as well, there's what we call headspace. So above the rock itself, or the regolith pieces that we have there, there's a bit of just Martian atmosphere. And the Martian atmosphere is also a really important target that we are interested in collecting as a way to understand a lot about the climate of Mars, a lot about what current environment is like on Mars, but it also that can tell us some about the past history of Mars as well. So those atmospheric samples that we're getting with each rock that we're collecting, and potentially in individual tubes as well, are really important samples as well.
Speaking of Mars, we have a question from Brian who asks, as you update the Mars architecture, are there advancements in the mass to Mars or increasing the technology readiness level? Nice question, Brian.
So I can answer that some. Like I said, we have loaned some of our the Exploration Systems Development Office architecture team folks into the studies who are very familiar with the current systems we're developing for human systems, including HLS vendors, including SLS Orion, and even like rover technologies that we're using and stuff. So yes, we are providing that information. We're providing studies that could include other systems, as well as our Space Technology Mission Directorate, who has some technology projects they were working on. There's a number of possible contributions that could be made considering the broader NASA portfolio, and everyone's sort of looking for all the innovative solutions. So yes, so if those could be applied and solve a problem or make it better and more efficient, we are considering those options.
Can consider that. A question here from Jody who asks, can you discuss sample return versus advancing robotic technology instead?
Yeah. So, when we as Mars scientists think about sample return, or when anybody who thinks about what another planet is like, another surface of another body in the solar system is like, there are certain things about sample return that are really appealing, and certain things that can be measured with sample return, that the amount of robotic technology advancement you would need to be able to make comparable measurements in terms of precision and accuracy and things like that. It turns out in the end, it actually is easier to bring the samples back and measure them here. If you think about things like synchrotrons and other things, that these huge instruments, or some of the measurements that we can make where we're measuring sort of individual atoms and down to that level, you just can't bring something like that to another planet. You can take those samples back and make those measurements. And then the other thing about bringing samples back to Earth is that you can do science in the iterative way that we are used to doing it. So you have a sample, you make a measurement, you understand something about it, but it brings up another question. Well, if that's what this is like, well, what about this other aspect of the sample? And you're able then to take that sample to a different instrument in a different lab or something like that, and make those analyses in that sort of iterative fashion. When you bring robotic technology to another place, you have to sort of guess what you're going to want to measure. Even if you can, interchange, sort of advancing robotic technology. One thing that folks talk about is, well, you bring lots of different instruments, right? And then you can sort of swap them out, or you can make all those measurements in a single facility or something like that. That's going to be limited because you still have to have guessed, we want to be able to make this range of measurements. And so, there are certainly things that we are doing to advance robotic technology, but there are things where bringing those samples back can really advance the science quite a bit.
Yes,
and I'll just add a little bit to that. So one of my favorite things that's happened recently, so Apollo brought back about 800 kilograms of samples from the moon, some of which were never open. And we opened just a year ago or so, year and a half ago, one of the Apollo sample tubes that had been completely sealed at vacuum on the moon 50 years ago and had laid in the vault at JSC. That sample tube has been opened, and now we're doing new science with it with the modern tools and technologies that they didn't have in 1969, 70, 71. So, by bringing those samples back, it's who knows what we can do with it in the future as well.
Mm-hmm. Yeah, that's a great thing. We think about that's certainly part of what we're planning with the samples, the Mars sample return samples as well, right? You are collecting these samples not just for the scientists of today, but also the scientists of the future.
Is there, Najida, is there any timeline estimation when some results from the sampling, taken from the moon, we're doing the testing 50 some years later? Any timeline when we can expect to see an update? Like, what breakthroughs do we get from that?
I don't have details on that. I know you can Google it. They have a bunch of articles, pictures of the samples. They were even, part of it was testing the techniques. So when we start bringing new samples back from Artemis, we know how to handle them again, because it is different people managing the samples today than it was 50 years ago. So no, I don't have details on some of the modern new science they're doing with it, but it is really awesome and fascinating to see those things happening.
Yeah, absolutely. Well, I see we have a question from 5-year-old Adeline, and love that we've got a young space enthusiast with us. Her question is, if we can visit Mars moons as part of going to Mars.
Well, one thing I will say is that, there are missions planned to Mars's moons to try and understand those two enigmatic bodies. Mars's moons are not like our moon. They are much, much smaller to Mars, relative to the size of Mars than our moon is. One orbits backwards, which is also very interesting. And so, not NASA, but JAXA actually has planned missions to the Martian moons. And, the ability to understand the whole system is certainly something that we would be very interested in. Najud, are we planning on sending humans to the Martian, Phobos and Deimos?
I'll say it has come up. It has been studied. And I'll say one of the fascinating things I've heard, right? They are so small, as you mentioned, that in theory, if you tried hard enough, a person could jump off of it. So, that's one of those things we have to consider before we start sending people somewhere, that they're so small that you've even got maybe not enough gravity to be safe, perhaps. So, if you did send people, we have to make sure we're considering things like that.
ConOps would have to be very specific on what people are doing.
Yes. Testing all the scenarios there.
Mm-hmm.
I see we have a question from Fritz, who asked, will later Artemis missions develop a closer lunar orbit cycle instead of the current cycle?
Yes, so very familiar with this piece. So in Artemis, our orbit ConOps, our mission designs are using what we call a near rectilinear halo orbit. So that's a whole lot of words to say. It's actually a orbit that's in the Earth-Moon plane. So it's still influenced by both Earth's gravity and the moon. And we're using that orbit, and it orbits. It's a 7-day orbit period. It orbits over the North Pole, very close to the moon, and very far away from the South Pole, because one of the things we're trying to achieve is the science missions at the South Pole, the areas of light that we can deploy infrastructure at, things like that. And the reason we're using that orbit is because it's balanced in that Earth-Moon gravity. So it's very easy to get into, and it's very easy to get back out of. So if we want to stage future Mars systems, future Mars technology needs, we have that option. And we also can use it to get down to the South Pole of the moon every week. So there's a lot of trades that went into figuring out that orbit, and that is Artemis's mission design. So we will use low lunar orbits for staging for the humans to get both to the moon and back again. Comm satellites will be in different orbits, but the human missions are going to, continue with that near rectilinear halo orbit.
There you go. We've heard so far JAXA, and I've heard ESA. So that brought up a question that I had about kind of partnerships. So we know that the space industry is evolving rapidly, embracing both public and private partnerships. I've had the opportunity to speak with other experts from, again, both sectors, private and public, and each has provided some insights. So I'm curious to hear, how do you perceive the collaboration between other government space industries like ESA, like JAXA, and the private sector influencing the future of exploration beyond Earth?
So I'll start with that one. So Artemis Accords is a policy document that we've started, and I believe we're up to 39 or 40. There's so many countries that have signed it. I actually can't keep up with how many have signed it, but it is, the principles by which we explore. And it's also a recurring tenet in our Moon to Mars architecture, is to enable international collaborations. When we explore, we do so on behalf of humanity and according to the principles laid out in the Accord. So we already have partnerships all over Artemis, so to speak. So ESA is a part of the Orion spacecraft, right? They're building the majority of the service module. The gateway systems already have partnerships with ESA, JAXA. The United Arab Emirates was recently announced as building the airlock. And we recently announced with our partnership with JAXA for the pressurized rover on the lunar surface. So, and there are more partnerships, and I won't continue to name them. But fundamental, how we learned, especially in human spaceflight, to work on the International Space Station, we are carrying that forward to the moon. We spend a lot of time working with our international partners. It is a very exciting part of my job. to get to do so. And I really enjoy the fact that we are exploring as partners and collaborating on all systems, literally all over the moon and around the moon and Earth.
And, you know, and from a science perspective, from a robotic exploration perspective as well, right? The data that is collected by, you know, the UAE's orbiter, you know, around Mars, the data that is collected by, you know, different things that are operating on the surface, and all of the different missions, it doesn't matter where the data comes from, you know, it helps us to improve our understanding of Mars and as well as other places in the solar system. So, you know, for us, any mission that goes out and explores and helps us to understand more about the solar system and beyond is a really exciting thing, because that data helps to improve our science and our understanding of things, you know, as humanity.
Mm-hmm. I love that. I love that you both have mentioned humanity, that the effort that NASA, its partners with other government agencies, private, again, is to do research that's going to benefit all of humanity. You know, not just us here in the U.S., but everybody, all of humanity that has come and those that are going to come. So I appreciate that you both had mentioned that. That's something that I try to highlight when I'm talking to people about space and why this is important. And when I get to meet people out in public and they're like, why are you so interested in space? Like, why is this important? And I'm like, well, let me tell you. And here's a long list of reasons why. But I love that you both mentioned that. Okay, we've got a few more questions from audience. I love that you guys are submitting these. A question from AC. Can we take plants from Earth that may survive on Mars, like a moss called, oh goodness, Synthotria caniverus? Rough. Latin is not my second language.
On the pronunciation.
There we go. Yeah. Okay, abbreviations, acronyms, pronunciation, not my strong suit. Or is there conflict with planetary protection rules?
So current planetary protection rules say that you can't bring something like that to a plate, you know, the idea is we want to minimize the contact of the Earth biosphere to, releases on other planets, other places in the solar system, especially places like Mars, where we think there may be some evidence, or there may, we're hoping to find evidence of life in the past. And so, things like that, and understanding how these different organisms can live in Mars-like environments. One of the things that I do, wearing my astrobiology hat, is try and understand, and we fund a lot of research in NASA about how different types of organisms live in these sort of extreme environments that we may see on other planets. So right now, things like that are the kinds of things where we would want to understand, what are its adaptations? What are the things that allowed this moss to live in the environment that may be like Mars? Why would it want to live in a place like Mars if it has, the environments that it does on the Earth? Because those types of adaptations help us understand what life elsewhere may be like. And so, in terms of planetary protection, we want to be very careful about bringing things from Earth that may grow on other places, because that could not only contaminate that planet, but it could also contaminate our ability to understand that planet. If we are looking for life on another planet and we're bringing life with us, that makes it very difficult to understand what we're finding if we do happen to be have that really exciting conclusion of finding something elsewhere.
Mm-hmm. How does that apply potentially with the Mars sample return to follow the planetary protocols? What does that look like with bringing the Mars samples back?
Yeah, so that is a really important question that we have been spending a lot of time working on. We are in the process right now of there's a Tiger team that has been operating for the past 6 months or so, the Sample Safety Assessment Protocol Tiger team, SSAP. Of course, it's an acronym. And that group has really been working sort of with folks from the CDC and with folks from ESA and sort of partnerships as well, back to this sort of, we got to understand, as a global science community, what we're looking at here. But that SSAP has been working on, okay, how are the ways that we could look at the samples that we have and understand what's there? If we find something there, what are the protocols that we would take? If we don't find something, what is the statistical analyses and the understanding we have to make sure that we're confident in the measurements that we've made and that we're confident they're safe? The samples will be kept in containment in a facility until we can either have an assessment that some assessment and some assurance that they're safe, or until we can find, they can be sterilized and released as safe.
Understood. Well, speaking of the samples, we've got another question here. Are there plans to leave Earth samples on Mars and then return to them later and study the changes?
I do not know of any samples, any plans. Certainly NASA does not have plans to leave Earth samples on Mars and then return to them later to study changes. That's an interesting prospect. I think that there's certainly ways that we can mimic some of the environments, the rocks and things like that we would bring to Mars. Mars is a terrestrial planet, just like the Earth. And so we wouldn't necessarily expect that if we brought rocks from Earth to Mars, that the environment on Mars would be all that different. And if we're thinking about biological samples or other things like that, there are ways that we can mimic those Martian environments in laboratories here on Earth and do a lot of those same studies. So I think that there are easier ways than carrying rocks to Mars to do some of those same studies.
Mm-hmm.
So I'll give you a different perspective, though, from the engineering side. So one of the biggest engineering challenges is how our materials degrade over time, how our rockets might degrade. So to me, the samples in this case might be your spacecraft or going and getting a piece of one of the rovers that has died and, how did it fare over time? So we've done all sorts of long duration exposure experiments on the space station. A lot of them happened on the moon. We'll do more on the moon. So it isn't always just the sort of the biological and geological samples. Data comes in all sorts of forms, including engineering data.
That's a really good point. That's a really, really great point.
I like the angle you took on that one. Let's see. Another question from Phoenix. Will any future Mars sample return mission integrate life support system experiments?
I'd say we already did one. So currently operating on Mars, I think, and you can correct me, Lindsay, it's on Perseverance, is the MOXIE experiment, which was experimenting with extracting oxygen from the Martian atmosphere. And it has been successful. So they have successful, very small amount. It was an experiment, but they have successfully extracted oxygen from the atmosphere. So things like that are discussed and talked about on all of these missions. So it's not truly a life support system. It is not producing a full atmosphere in a contained environment. No one's breathing it type thing. But those types of experiments are already being done.
There we go. All right, I'm going to jump into a couple other questions that I had for you. So oftentimes with Red Planet Live, we get a lot of young people, a lot of students, a lot of individuals who are not necessarily from the science community, but they join because they want to learn more. And so I have a question here about students and what advice would you potentially give to young aspiring professionals that are aiming to venture into careers within the space industry, particularly those that are passionate and about contributing to human space exploration?
So I'll start. I think one of the most important things is to try a lot of things. So go into a degree, and when you're in school, you're really just learning how to solve problems, answer questions, learn the fundamentals. You really learn how to do the job when you're doing it. So I encourage everyone to go get lots of internships or co-ops or work in a lab at your college, all those things, because you need to try a lot of things to figure out what you like best.
That it's almost the answer that I give is very similar. The answer that I always like in that way is take every opportunity that you can. Right? It's funny how many times you may find yourself taking an opportunity that seems kind of interesting, and maybe it winds up not being the job that you want or leading you down the path that you're interested in, but you'll learn something from that opportunity. And usually it's more than just, that's not a thing I'm interested in. But there's things that you'll learn from each of these different experiences that'll help you, in unexpected ways down the road. It's an opportunity to take a window, to look at something new and to learn something new, but it's also an opportunity to learn a whole wider set of skills that you may be able to apply in different ways down the road. So take every opportunity that you have.
I would agree with that. Yeah, every opportunity is a learning experience. And again, like you said, you may know, hey, this isn't what I want to pursue, but I've learned something and I can apply that skill to a future opportunity. Typically, when I'm interviewing guests that come on, we always are curious about their background. How'd you get interested in space? So my question to you is, obviously I've had a chance to look at your backgrounds, which both are incredibly impressive. Can you recall a specific moment that ignited your passion for space exploration?
Well, so I like to joke. I grew up in Jupiter, and actually I am from Jupiter. It's a small town on the east coast of Florida. But the neat thing about growing up in Jupiter is it was close enough that as a kid I could watch space shuttle launches. And so, outside, when the weather was, when the weather was right, you could see the shuttle launches from where I grew up. And there was something about, for me, growing up, knowing that people were going into space, that this was a thing that happened, right? Not that this was, science fiction, but that people were actually going into space to understand things, to learn new things, to explore. To me, I think it just set in my mind that this is just what we're doing. And so, I think for me, I have always been interested in exploring space and the search for life and that sort of thing. And it was just from that young age, just knowing that that was an option and that was the thing that was happening was a really big deal.
I love it.
Yeah, and I grew up on the completely opposite corner of the country in the Pacific Northwest, not watching shuttle flights, but except on TV. But I mentioned Star Trek earlier, but growing up, those were normal things. We had our science fiction shows. We also had people going to space. It was the shuttle, but particularly, I always loved reading about Apollo and exploration and going beyond. So I always wanted to work in human space flight, just sort of in my blood, so to speak. So it was always the thing, and then getting into it and then getting to build the space station and things like that. So it's just sort of in my DNA.
Mm-hmm. I love it. Another Pacific Northwest gal. I'm also from nice to meet a fellow space enthusiast and Pacific Northwest person. Let's see, I've got a couple more questions here. Keep them coming, guys. Is it better and less expensive to have astronauts pick up the samples, I imagine, than the Mars sample return? Is it better and less expensive to have astronauts pick up the samples?
I'll go with
you take that one, did you?
Scientists tell me it's better because the human brain is there and can be much smarter about what's happening and work more efficiently. And Perseverance goes 200 meters a day, and and humans can go kilometers worth of exploration in a day. It is certainly not cheaper though, right? Humans are big. Humans need a lot of systems. We have to have a lot of safety and redundancy and things you don't have to have with robots. So certainly better, but also certainly more expensive.
I 100% agree with both of those. Although I will add, one of the things I think we've learned from having so much of these sort of, robot geologists that we've had on Mars and operating on Mars is that there's some things, robots will not, do not explore as quickly or as, sort of looking into the full context as well as humans do. But, there are times when I used to do field work where I would have loved some of the instruments that were on Percy. So I think, to me, robots and humans together exploring a surface, a planetary surface, would be a really powerful combination, right? Because there could be this, the robot can make these measurements and the humans can see the context and, and really working together. So, but definitely not.
Those are a lot of our objectives in the Moon to Mars architecture is how do we do proper human robotic exploration of the moon so we can extend that to Mars.
Yeah.
Mm-hmm. Speaking of the moon, we get a question here. Is there a plan for NASA to establish a lunar base on the moon?
So we have a lot of objectives. In fact, there are 63 Moon to Mars objectives. Many of them have to do with the moon, and we are using those to drive the systems we need. To achieve all of the science objectives that we're being asked to achieve all the technology things, we will need longer duration human presence at the moon. So we are currently working on, I mentioned the pressurized rover earlier. We are also working on some initial habitation. So you can call it a base, you can call it whatever you want. We are looking to deploy the systems to enable crews to be there for longer, to do more exploration, to achieve the objectives we need. So yes, how we deploy the systems is part of what we're still working on, but we absolutely will need more systems, more habitation on the moon to do so.
Mm-hmm. Okay, so there's a plan there as well. Another question that we got submitted was about, again, about some international capabilities. We're seeing growth with international capabilities. How do you see NASA working with international partners to address key science questions, exploration, and future infrastructure of Mars? That's a long one.
Well, I mean, I think, for example, MSR is an international partnership, right? And in addition to partnering with ESA on MSR, NASA is partnering with ESA on the Rosalind Franklin rover. And I think that, a lot of the way we're thinking about the future of exploration is partnering with other international space agencies, because I think that there's a lot of different strengths that different groups can bring. And I think that also it allows us all to be working together to a common goal. And I think that's really important. And so I'll, Najut, if you have specifics about.
I mean, it just to the point that it's so hard. Mm-hmm. And it will take so many systems and so much scientific and engineering knowledge that the only way we will go is by collaborating and bringing the best of humanity, because we really can't do this alone to achieve it.
Yeah.
It's gonna take a whole
world
of everybody. Yeah, literally.
Not just a village, it takes the whole world.
Yeah,
everybody. Let's see. One more question. What are you most excited about? I think they're asking in terms of like future missions, different objectives that NASA is working on. What are you most excited about is the question.
I'm excited to get to be a part of it, right? I grew up, we were in low Earth orbit. Most of my early career was, I always wanted to do stuff to the moon, and we're doing it. We are doing this today. We're going to send people to the moon. We are sending robots onto Mars. We will eventually get there, right? This is what we all talked about, and now we're doing it.
Mm-hmm. For me, what really excites me is the fact that every time we send a spacecraft somewhere else, we start with a whole set of assumptions. Well, we're pretty sure that it's kind of like this that we've seen before. Here's an analog environment on our planet that we can use to test things, and we think that that's to first order what's happening on this other planet. And every time we look a little bit closer, we realize that, yeah, okay, maybe to first order that makes sense, but there's so much more happening. Right? We thought for a really long time that Mars was very, very much like the Earth, right? To the point that we thought that there were things, vast civilizations on the surface of Mars. And the more that we've learned about it, the more it sort of resolves to a different kind of picture and helps us to understand that, each of these places, each of the bodies in our solar system, the planets, the moons, the asteroids, are unique and interesting places. And overall, it's just developing this so much more complex picture of what our solar system is like. And then that helps us think, to the very first question about, that exoplanet in the future, what those environments are like. For me, fundamentally, the search for life and trying to find out that very fundamental question, is there life somewhere else, either within our solar system or beyond our solar system? Just the vast number of different environments that exist out there just means that there's so many different places to look and so many different ways that life may be somewhere else. And I think that that's just so exciting to me.
Mm-hmm. And it's important enough that you're going to dedicate, your work, your life mission to being a part of this. Najut, I like what you said. I just want to be a part of it. I'm excited to be a part of it. I feel the same way. People ask me like, hey, would you ever go to Mars? I'm not sure I'm the person that wants to go to Mars, but I just want to be a part of it. I just want to contribute to the effort. I want to see humans get there. I am okay not being the person that steps foot. But if I can contribute, if I can have these conversations, if I can bring science education, space information to the public, I feel like I'm contributing to the effort, even if it's a small amount. I'm happy to have these conversations and get to interview individuals like you both. So thank you so much for being here today, for answering all of our questions. You guys did great. You tackled all those questions that we got from the audience and did it so gracefully. So thank you both so much for being here today.
Thank you.
Thank you, Ashton. Have a good night. Thank you, everyone.
Thanks, everybody. Have a great rest of your evening. Special shout out. Thank you to our friends at Liftport, Michael and Leah. Thank you to Michael Stoltz, our PR director. Thank you to our executive director, James Burke. So glad to have all of you today. It was another great episode. Hope to see you all in August at the Mars Society Convention in Seattle. And as you've heard me say before, and I think we alluded to this a little bit, the best is yet to come. All right. Thanks, everybody. Bye-bye.